We are going to cover lesson 52, so I'm going to jump right in. 52.A covers the inviolable argument, and that just means the argument cannot be changed. So, for example, if I have the tangent of 2 theta equals 1. First, let's cover, if you missed that section, let's cover the part that's the argument. So this is the argument, and we cannot move the 2. Okay, it stays together. And so that is what this is covering. You need to leave it, and this will affects the domain of the angles, okay? So it changes how many answers we have. We're not actually using it to solve. So 2 theta affects the domain of angles. That can be a solution. Okay, so we're going to see that here. We are going, and so for example, another example, the tangent of 2 theta minus 3 equals 0. Know that I cannot move 2 theta, but I can move the 3. So I would be solving the tangent of 2 theta equals 3. Okay, but we cannot move the 2. So that's all that 52.A is covering. How the argument you're going to leave, whatever's in front of theta, you're going to leave alone. So let's jump into 52.B, which is where we're going to spend the rest of our time. And we are going to be solving trig functions that have arguments. So arguments and trig functions. And hopefully, this should say trig equations. And hopefully you're following along. I'm going to do 4 examples. All right, so let's first review how I solve. So for example, number 1, this is review. Let's say I ask you to solve the, let's see, where should we start? If I ask you to solve the cosine of theta equals -1 over root 2, and we're going to use the following domain, that 0 degrees is less than or equal to theta, which is less than 360 degrees. And we use this domain almost every time, okay? So this is review. So I'm asking myself what angles produce a -1 over root 2, right? That is what I'm asking when I'm solving. So I'm dealing with cosine. All students take calculus. Cosine is negative in these 2 quadrants. Cosine is negative in these 2. So first I'm going to use my reference triangle, right? This is my 45, 45, 90. Because there's a root 2, I know I'm talking about 45. So in this quadrant, right, it would be here, and in this quadrant it would be here. So this quadrant would be 180 minus 45, and this quadrant here would be 180 plus 45. So my 2 theta could be 2 possible angles. 180 minus 45 is 135. 180 plus 45 is 225. And so those are the 2 solutions that would produce a -1 over root 2. Okay, so let's start with today's solve the cosine of 3 theta equals negative 1 over root 2. Okay, so from example number 1, I know that the two angles are 135 and 225. However, this affects my domain. So let's go over here. If my domain is 0 degrees is less than or equal to theta, which is less than 360 degrees, I have 3 times theta. So I actually have to multiply both sides by 3. This is saying 3 times theta. So I'm doing that to each side, and I get 0 degrees is less than or equal to, and if you'd like, this is 3 theta. 3 times 360 is 1080 degrees. So this is my new domain. So notice I can have angles up to 1080 degrees. So I know my two original from the previous example, right, is 135 and 225. Okay, so I'm going to set up, if it helps you, I have 2 columns. Now, because I have 3 times theta, I can do additional rotations of 360. So because I can go all the way up to 1080 and 3 times theta, I'm going to add 360 because I know that the angle 135 shares the same terminal side as 360 plus 135. And so 135 and I believe 495, these are reference angles or related angles because they share the same terminal side. They would still produce 45 degrees with the x-axis. So I'm going to add, and that gives me 495, and this gives me 585. Now, I can go up to 1080, so I can do another rotation of 360. That here gives me 855, and here that gives me 945. Now, I cannot add another 360 because that would produce 13, and this would exceed domain. So I'm going to stop. Okay, so I'm going to look at my angles that I have. Don't pay attention to the 360. I have these 2 original from the last example. I have these 2, and I have these 2. So 3 times theta equaled the following angles: 135, 225, 495, 585, 855, and 945. But if I was to plug these angles into the original, I would be multiplying these by 3, and then that would greatly change them. So I need to solve for theta, so I'm actually going to divide all of these by 3 to solve for just theta. So I'm going to divide each of these by the number in front of theta. 135 divided by 3 gave me 45. 225 divided by 3 gave me 75. 495 divided by 3 is 165. 585 divided by 3 is 195. The last 2 divided by 3 gave me 285 and 315. So these are all the angles that if I plug them into here, 3 times theta, I would get a ratio of negative 1 over 2 because they would all end up in these 2 quadrants. They're just rotations of a 360. So I'm going to do 3 more like that so you get kind of the full process. So here we go. So we're on number 3. So solve the sine of 2 theta minus 1 over 2 equals 0. Now, the first thing we need to do is isolate the trig function and the argument. So I'm going to get this part by itself, and I would do that by adding 1/2 to both sides. So I'm solving for the sine of 2 theta equals 1 over 2. Okay, so this is what I'm solving for. So what angles, right? What angles would produce a positive 1 over 2? So I see that and I think of my 30, 60, 90, right? This is 60, this is 30. So 30 degrees would produce 1 over 2. So I know I'm working with the related or reference angles of 30 degrees. Now I have to figure out what 2 quadrants is sine positive in, right? This is a positive 1/2. So all students, I'm looking in these 2 quadrants, right? Not these, because sine would be negative down here. And so that'd be 30 degrees here. But in quadrant 2, that would be 180 minus 30 degrees. So my 2 angles are 30 degrees, and this would be 150 degrees. So if you can see it, let me highlight. My 2 angles would be 30 and 150, but I have 2 times theta. So 2 times theta would 2 times 0, whoops. My original domain is 0 degrees is less than or equal to theta, which is less than 360. But I have to multiply everything by 2, right? So 2 times 0 is still 0 degrees is less than or equal to 2 times theta, which is 720 degrees. So I can go up to 720 degrees. So let's start with adding a rotation of 360 to the 2 angles that would produce. This produces at 30 degrees because I would be using this triangle here, right? And this triangle here. Okay, that's why 150 works. So this gives me 390. This gives me 510. Next one. Can I add another 360? Well, this gives me 870. This gives me 750, so I cannot. So I would stop here. So I'm looking at these 2 angles, and then after adding 360. So 2 theta equals 30, 150, 390, 510. But in order to solve for theta, I would have to divide everything by 2. So theta equals 15 degrees, 75 degrees, 390, 195 degrees, and 255 degrees. So those are the 4 solutions that if I plugged them back into here, I would be solving. Okay? So if you're just looking at my notes, this would look a little, this is the original. Okay, but I added 1/2 to each side. All right, next one. Just to give us adequate practice, so the cosine of theta over 2 plus root 3 over 2 equals 0. All right, now remember, I cannot move the argument, but I do need to isolate it so I can solve it. So I'm going to rewrite this to be the cosine of theta over 2 equals negative root 3 over 2. Okay, as soon as I see a root 3, I think of my 30, 60, 90 because it involves root 3. Cosine would be adjacent over hypotenuse, so I'm dealing with 30 degrees, but this is negative. So all students take calculus. These 2 quadrants cosine is positive in. So these are the 2 quadrants in which cosine is negative. So I'd have a 30 degree here and 30 degree here. But what angles would produce that? This would be 180 minus 30 to find what that angle is. And this down here would be 180 plus 30. So I'm working with 210 and 150. Now, this is where it gets interesting. If this is what I'm solving for, let's talk about theta. 0 degrees is less than or equal to theta, which is less than 360, but I'm dividing everything by 2. So I have 0 degrees is less than or equal to theta over 2, which is less than 180 degrees. So this is the domain. I'm solving for this. With this domain. So, look at our two angles, ladies and gentlemen. I have 150 and 210. So, I cannot use 210 exceeds domain. So, I am just solving for 150. So, theta over 2 equals 150. I can't use 210 because it exceeds our domain. But then if I have to solve for theta, so theta equals 300. Now you're probably thinking, hey, that exceeds the domain. Yes, but you're plugging it into here, which is going to cut it in half. 360 divided by 2. You're plugging it into the original function. Theta divided by 2 is 180. I can't use the 210 because it exceeds my original domain. So I only have one solution, and that is here. Okay? I know that is kind of confusing. So let's do the last one. Solve the tangent of 3 times theta plus 1 equals 0. So let's rewrite this. Remember, I cannot separate the argument, so I would simply subtract 1 to the other side. So this is what I'm solving for. I'm now going to adjust my domain. So 0 degrees is less than or equal to 3 theta, which is less than 1080. This is 360 times 3. Okay, so here's my domain. Now, this has a ratio of -1 over 1. So I'm talking about the only triangle that has 2 ones is the 45, 45, 90. So what 2 quadrants am I negative in? All students take calculus. I'm positive in these 2, so I'm negative in these 2. So I'm looking for the 45-degree angle here and here, right? So this would be 45, and this little guy here would be 45. So this in here, this would be 180 minus 45. This quadrant would be 360 minus 45. So this is, I believe, 315, and over here 135. So those are my 2 angles. So I'm going to set them up here. 135, 315. But because I can go to 1080, I can add rotations of 360. So I've got 495, 675. I can do another 360. I'm not to the 1080. And that gave me 855 and this is, oh, I did this wrong in my original. Sorry. This is 1035. And so obviously if I'm at 1035, I can't do another rotation of 360. So I'm paying attention to these. Right? I'm not doing the adding of 360. Those were the results. And in order to solve for 3 theta, what am I going to have to do? I'm going to have to divide. And instead of writing it all out, can you guess what you're going to do? I'm going to have to divide all by 3. So theta equals 135 divided by 3 is 45. The next one is 105. I just do it in order using my calculator. I got 165, 225, 285, and the last one I did wrong in my notes, 1030. 1035 divided by 3, 345. And so these are all the solutions that would produce a negative ratio of 1/1. For homework, and I should probably write it somewhere legible. I'm going to probably have to go to the first page, so just give me 1 second here. So for homework, go ahead and skip numbers 6 through 8, 16, 21, 23, and 27. And that concludes lesson 52.